All right, now before the break, we are looking at how the exponential smooth forecast we're doing, and the effect if you too heavy, what happened? And it's not too heavy, but if you increase further the alpha, what happened? All right, if you have a light forecast, what will happen? Yeah? Now we learn another new things after the break. It's called adjusted exponential smoothing. Just now, it's called exponential smoothing. Now we add one more, means we do some advanced improvement on the mathematics model. I fall under, we give you a name called adjusted exponential smoothing. Give you by this formula. So here, I adjusted exponential smoothing, I add a in front. It's not a constant or something, but it just means that it's an adjusted exponential smoothing. Same focus t plus 1 equal, but now for adjusted exponential smoothing, the right hand side calculation is a little bit different, where you use forecast t plus 1, which is the next forecast plus the next t here is a trend factor. T here is a trend factor. So when you talk about adjusted exponential smoothing, you using a trend factor. Okay, a trend factor. So this is another equation for second session. We'll go through one example, then we call it a day, right? So adjusted exponential moving, we need two data. One is the next month forecast, or the t plus 1 forecast plus the trend factor. There's an equation to calculate trend factor, a long equation, right? A long equation. So t plus 1 equal beta ft plus 1 minus ft plus another component 1 minus beta t. It is trend factor. So the front, this one is forecast value. This one is a trend factor. Okay, a little bit complex compared to the previous one, but there is some advantages if you use this formula. You will see from the graph later. Huh? So just copy this equation. Adjusted exponential smoothing, AF sub t plus 1 equal to forecast t plus 1 plus t plus 1. However, there is one more equation to calculate this one before you can get the adjusted exponential smoothing forecast. You need to calculate the smoothing trend factor here by using this equation. There's a beta there. Beta is another constant you use to smooth the trend. Okay, beta is to smooth the trend. Alpha just now is to smooth the forecast. Okay, beta is to smooth trend. Alpha is to smooth forecast. So the beta value here, if you want to get close to the trend that you see in the graph, or trend of the data either going up, or it's a cycle, or it's a seasonal, then you use closer to 1. Beta you use closer to 1 if you want to close to the trend. Okay, but normally we don't use extreme case like 1. Conservative, you use 80%, right? Beta 80%. Okay, so Let's see example. Let's see example. Example number 4. We use back the previous example 3. Still the computer service company. Now you want to use adjusted exponential smooth forecast for the same 12 month, same demand. Okay, it will use the exponential smooth forecast alpha 0.5 compute in the example 3 with a smoothing constant trend beta 0.3. Okay, we recall the same table. You have the period from 1 to 13, month from January to December, and then the next year, January. You have the demand, that is the real data from 37 to 54. And then you build new column, new column, new column. You have the same table in the tutorial handouts, right? So here you have forecast FT plus 1, trend T plus 1, adjusted forecast AF T plus 1. So by looking at your table, basically we know what you're calculating. So for adjusted exponential, you need F plus T, you need trend, you need adjusted forecast value. So you have 3 new columns here. So the formula for the adjusted exponential require initial value of T to start the computation. So, and the trend, the initial trend value that you use is actually also based by experience and also trial and error. It's very subjective. There's no one perfect value for that. Okay. So in this case, we will use back the demand value again to kickstart the calculation. So in this case, we use the trend value. The adjustment for the trend is 0. Yeah. Because you look at the adjusted formula here. So adjusted formula trend here, in the trend calculation here, you are combining the forecast and the trend value. So for the first one, to calculate the T plus 1, our T here equal 0. Okay. Okay. I pull the table to a new slides, whereas we focus on the table alone. Again, you have the same table in your tutorial handouts. We try to do first one. Recall the question gives us alpha value, beta value, alpha 0.5, beta 0.3. We try to solve the first 3 first, and then I give you second, and then maybe I forget whether I did the third one, but at least I show you 2. So for the first one, we don't have trend. For the first January first month, we don't have trend. We don't have adjusted because first month is the beginning of the data. We don't have something to forecast. So it's 0, 0. Then to kickstart the calculation, for the adjusted exponential equation, we will use the demand value to be our forecast, F1 here. Okay, this is F1, F2, F3, F4 until F13, like what you calculate just now. Okay, so the first one is F1. So we don't have forecast previously. So for the adjusted exponential, there is a value for F1. Take note on that. This is the difference between adjusted exponential smooth and the previous example we see before the break. Okay, before the break, we don't have value here. But here, we copy the demand into the forecast column here. Then we start calculation for the second one. We call the equation that we calculate just now, ft plus 1 equal to alpha dt plus alpha minus 1 alpha ft. Now your alpha value is 0.5. Okay, so for f2, is this one. f2, your alpha is 0.5. d1, this one, this is d1. 1 minus alpha. So now your alpha is 0.5. So 0.5. f1 is this one. This is your f1. So you put in the value with the alpha is 0.5 now. You get 37 service call. F2 is 37.00. Okay. I miss out the decimal place here for forecast value. Okay, forecast value, minimum 1 decimal place. I give 2. So this is just my draft for calculation. But when you put into the table, you should give at least 1 decimal place for forecast value. Okay, take note on that. Yeah. So from here, we get F2 value, 37. Okay, next we move on. Since once we have the first forecast value, we can do this one and this one already. Okay, let's apply. Okay. Apologize for this. I forget to hide this value, but we are looking at this. We're looking at these two space here. So I copy the equation to calculate for adjusted exponential smooth. AFT plus 1 equal FT plus 1 plus T plus 1. And calculation for T plus 1, there's another equation. So T plus 1 equal to beta Ft plus 1 minus Ft plus 1 minus beta Tt. So you have all the data here already. So if you want to calculate this one, this is T2. This is T2. T2. So T2. T2. So what is your T? T is 1. So this is also 1. So you get F2. This is 1. T also 1. The rest is substitution. Beta 0.3. 1 minus beta, 1 minus 0.3. So you get equation to calculate T2. Okay. You have your F2 and F1. You have your T1. Okay. T2.3, F2 37, F1 37. So 37, 37, 0. This one, why 0? Because we say that we use T1 equals 0. Okay. No data. T1 no data, so 0. So T2, 0 here. Sorry, T2 here. Then we back to the, okay, T2 is 0. Then to calculate AF, right, I should hide this number. But once you get your T2, go back to this formula. So AF2, this is AF2, the second number, AF2 equal, so AF2, this one also 2, this one also 2. So F2, T2. You already have your T2, 0. You have your F2, right? This is your F2. So AF2 equal to F2 equals 0. So basically, this one equal to 37.00. This one equal to this one. Okay. Next. I already show you the second two. Let's see. Let's do the third set. If you understand the previous two slides, you should be able to do the third one. Calculate the forecast using the previous equation. ft1 plus alpha dt plus 1 minus alpha ft. This is f what? 1, 2, 3. So this is f3. So f3, what is your t? T is 2. So this is d2. This is f2. Okay. This column here is f3. What is your t? T is 2. 3 equal to t plus 1. So your t is 2. So t is 2, f2. Alpha for this column here, we are using alpha 0.5. Why alpha 0.5? Why we choose alpha 0.5 again? Just now you see 0.3 and 0.5. So 0.5 is more nearer to the raw data. So that's why we choose between 0.5 and 0.3, we choose 0.5 because 0.5 alpha near to the real data, real demand data trend. Okay, the rest substitution like what you did just now. Okay, 0.5, 40, why 40? D2, this is D2. Okay, F2, what is the F2? 37. So for, sorry, typo error, it's not F2, right? Typo error, F3, typo error, F3 equal to 38.5 service call. So this is F3. Okay, again, typo error. Get the first number. After you get the first number, use the adjusted exponential smooth equation, calculate trend. Once you have the trend, you can calculate AF. Okay, I call the two equation out, same. AF equal to FT plus 1 plus trend. So how to calculate the T trend T plus 1? Beta something plus 1 minus beta T. You calculate the T plus 1 first. So T plus 1, you look at this location. This is 1, 2, 3. This is T3. So T3, what is your T? T is 2. So this one, same. 2 plus 1, 3. This one, 2. This one, 2. Okay. You get T3 because this is the third position. T3. Beta, we use 0.3. This is T plus 1, so follow the previous one. So your T, you know that is 2. So this is F3, F2, beta 0.3, T is 2, so T2. Okay, so what is your F3? F3 is forecast number 3, this one. What is F2? F2 is forecast number 2. What is T2? Trend number 2, this one. Okay, T2, trend number 2. Substitute the value, press calculator. Trend number 3 is 0.45. Substitute value here. Then once you have your T3, so AF3, this is AF3, 1, 2, 3. So AF3 equal to F3 plus T3. Okay, this is AF3. So what is your value for this one? So T plus 1 is 3. So F3 plus T3. You get this one. So how to calculate this value? You take F3. What is the F3? This one. What is your T3? This one. So AF2 equal to this one plus this one. You get 38.95. Put in here. Okay. Okay. I'm kind enough. Do one more set for you, just to boost your understanding. Now, by having the three steps just now I show you, are you able to do the fourth one? Huh? So first, what you do, you calculate the f plus t by using the previous example with the alpha. So ft plus 1 equal to alpha dt plus 1 minus alpha ft. Again, what is this number? This is f1, 2, 3, 4. This is f4. So f4, what is your t? T is 3. So f4 equal to alpha d3, 1 minus alpha f3. You should get this equation. So you want to calculate f4, alpha 0.5. Again, why do we choose 0.5 instead of 0.3? Because 0.5, the trend line just now, is nearer to the real demand trend line. It's nearer compared to 0.3. That's why in this example, we improve our accuracy of our forecast by choosing the closest one, alpha 0.5. Alpha 0.5 show a better forecast, right? So that's why we choose 0.5 than using 0.3. Okay, so back to this calculation, alpha 0.5 D3. How to find D3? Go to the table here. 1, 2, 3. This is D3. Then what is F3? F3 this one. Okay, F1, F2, F3. Press your calculator, substitute, press your calculator. You manage to find F4 equal to 39.37. You get this one. Then for the trend and adjusted, also use the same equation. You calculate the trend first. So this is trend number 1, 2, 3, 4. So trend 4, what is your T? T is 3. So trend 4 equal to beta F4 plus minus F3 plus 1 minus beta T3. Okay. Then go and find the information in the table that you calculate just now. F4, 1, 2, 3, 4. This is F4. F3, this one. T3, this one. Okay, you get your T4, 0.69 over here. Once you get this one, calculate AF. So this is AF 1, 2, 3, 4. So AF4 equal to forecast number 4, trend number 4. So trend number 4 you calculated already. So F4, where is F4? This one. Okay, press calculator, you get AF equal to 40.44. Okay, get these two numbers. Now, you see that if you are good in Excel, I'm not sure whether you take Excel courses before. You can use programming macro function to calculate, or simple programming in the Excel file. Just ask the Excel to import value from a certain cell in the Excel file, in the Excel spreadsheet, then do the same calculation according to this. These basically are repeated. There's a pattern of calculation here. So what you need to do once you complete the first and second row, what you need to do, you just drag the mouse. You go to, once you have programmed the Excel, you use your mouse, move your mouse to the lower right corner of the cell, and the cursor arrow will change to a plus sign. You press the left button of your mouse and drag. Same with this one. Once you have the second row, what you do, you move your mouse here in the Excel file. It will change from arrowhead to a plus sign. Hold down the left click and drag. Same with this one. You will get the same data as we calculated here. Again, too bad in the exam.net, I try to use the tools available there, but they are not very helpful. So it's way faster if you use the method we go through like this, one line by one line calculation. Okay, too bad exam.net don't allow you to use Excel, so too bad. So expect I will give you more times if this kind of question come up. This one will take you minimum 20 minutes just to calculate at least 10 data. Okay, just be careful when you calculate this one, because one individual number is wrong. One of it is wrong. The whole table is wrong. Okay, this one do more damage compared to the moving average question. Okay, this one usually will be in your final exam. Usually will be in the final exam. Final exam usually tests your awareness and also your detail in calculation. So one single mistakes in the decimal place here, you will get the wrong answer. You will snowball the error. So it's good when you come to adjusted exponential smooth calculation. I increase the accuracy to 2 decimal place compared to the previous one. Okay, previous one, I still can use 0.1 decimal place. But when it comes to exponential, I want to be more accurate, so I extend my decimal place become 2. Okay, give me more decimal place, yeah? Okay. I hope it's very clear. I show you four example steps from step by steps. You repeat the same for this column, and this column as your homework, yeah? Repeat until 13 data. Okay, you can use Excel. I explain how to use Excel, and if you want to know how to use Excel to program auto calculation or build a calculator in the Excel, you can just Google and how to program, how to calculate using Excel. There's a lots of video out there to help you to program. Huh? All right. So again, too bad in exam, the tools exam.net not allow you to open Excel software. Too bad. Huh? I hope they can improve on that. All right. So I give you the answer for the calculation. All right. So from here, you calculate the forecast 0.5, alpha 0.5, trend, and also adjusted forecast. So you get this table. Next, what you do, you plot this table into a graph form. On the left, also demand and forecast number. This is the month or period. Okay, month or period. So you can see that you have 3 lines here. First is the actual one. The actual one, the blue up and down, up and down. And then you have the alpha one, the forecast alpha 0.5, which is we plot previously. So we just copy the same trend inside here. And you see what happened if you use the adjusted forecast with beta 0.3. You see what happened to the line here. You try to observe the red color line and the forecast 0.5 line. You can see that the red line is a little bit higher than the forecast alpha 0.5. It's a little bit higher. It means that it's a little bit closer to the real data. So this is a very good estimation. Both also good, but one give you a little bit closer to the real data. Okay. So these are the explanation. All right. So as you can see, both also give you constantly higher than the exponential smooth forecast. So the line is a bit higher, red color line and the green color line. So as you near to the real data, it means you reflect, you have a very good forecast, a little bit more nearer to the realistic behavior of the demand. Okay, we stop here. Next class, we look at linear trend line. So let's stop here.